let's actually go to our lesson. So I just want to go back to this question we did on Tuesday, and there was some confusion, mostly on my part, about this question. I thought the question didn't work, but it does work. So just to reiterate, and you can take another screenshot if you want of this question. This is a parallelogram because the opposite angles are equal. Angle L is 56 and angle N is 56. And then angle P and angle M, they're both equal to 124. So our final answer should have been LNPN is a parallelogram because both pairs of opposite angles are equal. Okay. So I hope that clears it up, and I apologize for any confusion. Okay, we're going to carry on today, proving, and we're going to see how far we get. And we're going to start here tonight with the with this first question. Okay, so it says here, AC and DB are diagonals of quadrilateral ABCD. So OA is equal to OC. So straight off, I'm going to start by filling in the things that are given. AO is equal to OC, and BO is equal to OD. Okay, so the diagonals of this quadrilateral actually bisect. Okay. But that's not what it is actually asking for. That's just something that you can maybe notice. So once you have put down everything that's given, normally you would go on your fact-finding mission and you would start finding angles that are equal, other sides that are maybe equal. But in this case, that's all we have. We don't really have angles or anything of which we can do values, but we can maybe look at stuff like, okay, so O1 and O3, they will be equal. And remember, when you go on your fact-finding mission, do that in a different color. So the things that you find that are equal using other geometry, put that in a different color. And then O4 and O2 are going to be equal because they are also vertically opposite. I don't know if anyone else notices anything, any other angles or sides that are equal, but I think we can go to our questions. So the first question says, prove that triangle AOD is congruent to triangle COB. Okay, I'm going to leave you here for about 2 minutes to do that congruency proof. If you are not sure about something, then pop a question in the chat. You can send a question to Miss Kat, who, by the way, is standing in for Miss Coco this evening. We are happy to have you, Miss Kat. But you're a familiar face here with the grade 10s now.
Yeah.
You're just
I'm here often these days.
You're just part of the crew.
Even when Coco's back, I'm gonna come visit and just be creepy and watch you guys.
You should just do that. I mean, I do that sometimes with grade 7. I gave you guys such a fright that night when I just pitched.
We realized because Alona was like, I just realized there are 3 teachers. And I was like, no, there aren't. And I was like, wait. What?
I'm just like quietly hanging back. Nothing happened to Miss Coco Tsioma. She is just busy with other things, but she is absolutely fine. She will be back, I think, next week. Yeah. Remember Miss Coco had those exams and she wrote, I remember she wrote on Friday on discrete mathematics. I'm like, girl.
Another thing that's great about postgraduate is there's no actual maths. You just speak about maths.
You just speak about maths and you say how maybe you'll like think about the maths and how you'll get your learners to think about the maths, but you don't do the maths. Unless you're teaching discrete maths. No thanks. Anyway, so Miss Coco had that exam, and I think that is the reason that she's actually just tired, because that would have been a killer. Third year maths. Okay, so right, let's see how we're going to prove this congruency. Who wants to volunteer their answer? Let's see in the chat. You don't have to do the whole spiel. I understand that it is a bit of a schlep to type the whole thing out. Maybe I should just do it and you can check your work. I'm going to use this nice blue color. Okay. So you're almost a little puzzled. Aren't we all? Just a little puzzled. Okay, so we have to, in triangle AOD and triangle side angle side, Gabriel has started saying vertically opposite angles and two sides of both triangles are equal. Okay, that sounds like something, could be something. Okay, so what do we see in triangle AOD and in triangle COB? There's lots there. This is a very easy congruency proof. We've got AO equal to CO, and that is given. Remember, if you use your colors and you use a color for what is given, you just look at the color, then you know, oh, that's given. And then you just write given. You don't even have to think about it again. And then we're going to say DO or OD is equal to OB, and that is also given. And then we're going to say, as our third reason, that A2 is equal to, sorry, not A2, O2. O2 is equal to O4, and they are vertically opposite angles, vert-op angles. So therefore, triangle AOD is congruent to triangle COB. And what have I got? I've got a side and an angle and a side. Side, angle, side. Okay, so Lutando said side, angle, side. Gabriel said DO equal to OB, given. Yeah, good stuff. Monica, I think you are onto it. Okay, right, but a very easy proof there. Now you basically have to do the same thing for triangle AOB and triangle COD. No worries, Sibunga Muso. Okay, so if we do the second question now, let's do it in a different color. We've got, let's do this light blue. Now we have to do these two triangles. It's basically going to end up being the same thing, just the other way around. So we go in triangle AOB, and I hope there where you are at home, you are doing all of this so nicely with your layout. I can't see and I can't check, but this is what your layout must look like, okay? If I was there, I'd be checking that layout, because you guys always ask, is it worth any marks? It is not per se worth marks, but if your work is untidy, and it means that your thoughts are untidy and that you are losing sort of track of what's happening. So this is why we do a nice layout like this. Okay, statement, reason, statement, reason. And why do we write in triangle AOB? Because now, as you can see, we're doing two congruency proofs. There's 4 triangles here that well, there's many more than 4 here, but we have to specify which triangle are we working in. AO is equal to OC, AO, OC, and then DO and OB. And that is also given. And then O1, it's basically exactly the same. Why did I make a Q? O1 is equal to O3, and that is Watobe. And in grade 10, each of these are worth a mark. So statement with its reason is 1 mark. So therefore, we can say triangle AOB is congruent to triangle COD and its side angle side again. Okay, put a thumbs up in the chat if you got your congruency proofs correct. Thumbs up. If not, put a thumbs down. Okay, right. Now we've done this 2 congruency proofs. What is this going to do for us? We have to prove in part 3 that ABCD is a parallelogram in 2 different ways. Okay, so there are 5 ways, if you remember from Tuesday, those 5 ways in which we can prove a parallelogram. I'm going to put it here. Now look at what we've done. We've proven all this congruency. So which of these, we need to show 2 ways that will make this a parallelogram. So put in the chat, which 2 ways do you think we've got? I'm waiting for more answers, guys. 52 people. Two ways. So in your answer, you must give 2 ways. I think they are, we can do all these ways actually. Four and 2 says Klo. Okay, so can we say both pairs of opposite sides are parallel? Now, remember, congruency is a powerful thing because it gives you so many things that are equal. So I'm going to make in a different color, in red, those things that we get because of the congruency. So B1 will be equal to D2 and C2 will be equal to A1. That's just because of the congruency, because congruency means everything's the same. I'm running out of markers here, but B2 will be equal to D2, also because of the congruency. And then A2 will be equal to C1 because of congruency. So in actual fact, we can prove that the opposite sides are equal, the opposite angles are equal. And because of where those angles are, B1 and D2 are actually alternate. So we can prove that the opposite sides are parallel. And then we can also prove, obviously, the diagonals bisect. And we can also do one pair of opposite sides equal and parallel, because this side is equal to that one, and this one is equal to this one, all because of the congruency. Okay, so you can choose your two. I'm going to go with some of what you've said. I think because of the congruency, both pairs of opposite sides are equal, and both pairs of opposite angles are equal. Okay. So how do we write that? Remember, we always need to give our reasons. So our reason for AB equal to DC, AB equal DC is the fact that triangle ABO and DCO are congruent. That was in your first congruency. So you never write congruent triangles. You write which specific triangles are you talking about that are congruent. Congruent triangles is not a valid reason. Okay, so AB is equal to DC, and then we can say BC is equal to AD. And the reason for that is that triangle AOB is congruent to triangle COD. Therefore, we can say that ABCD is a parallelogram. Both pairs of opposite sides equal. Okay. And we can also do diagonals bisect, definitely. So diagonals bisect, that's all given. So if you go AO equal to OC given, and then OD equal to OB given, and then you write again, it's a parallelogram. Why? Because the diagonals bisect. Okay. Right. Anything in the chat? Okay, good stuff, guys. Let's go on to our second question. So ABCD is a parallelogram with angle B1 equal to 40. Okay, so it tells us that this is a parallelogram. Now we have to prove that it is indeed a rhombus. Okay, so what are we looking for if we want to prove that this is a rhombus? Which characteristic would we need to prove if we want to conclude that it's a rhombus? Which characteristic or characteristics? Put it in the chat. Look at your properties that you should have, a big diagram full of properties. The adjacent sides are equal and the diagonals bisect at 90. Good stuff. I think we are getting better at our properties. Now off you go and prove it. I'll wait here and then you can tell me what the answer is. How would you do it? So remember, you can start with the fact that ABCD is a parallelogram and you've got some angles. Okay, so our two options which will make it a rhombus is either that all the angles, all the sides are equal, or that the diagonals bisect at 90. Okay. Those are the one of those two things you need to prove. Nothing else. Either diagonals bisect at 90, or adjacent sides equal. Okay, so I'm going to give you 2 minutes to devise your plan and your strategy, and then I would like to hear from some people how they're going to do it. It's not a sides, it's adjacent sides. Okay, so 2 minutes are up. I want to hear what the plan is. Sandile seems to have a plan. Come, let's hear from some other people as well. What do you think? How are we going to do this? Gabriel says proof congruency. Okay, how are you going to prove the congruency, Gabriel? How are you going to go about it? Okay, we can't just have two people with ideas. Let's get some more ideas. How are we going to do this? Monty, I don't know what PRP means. Amika's also done a whole proof here. Wouldn't be angle, angle, angle because the diagonals bisected 90. Guys, we do not know that this is a rhombus. We have to prove that it's a rhombus. So if we're proving that it's a rhombus, we can't use its properties. No problem, Monty. Okay, so Sisipo says, okay, so you guys are finding some angles and stuff, but I don't think anyone has a plan yet. Okay, so the first thing that you were meant to have done is to work with what is given. This is what is given. ABCD is a parallelogram. So what does that mean? I can fill in the properties of a parallelogram here. The opposite sides are parallel. The diagonals bisect. Okay, and the opposite sides are equal. 1, 2, 3. Okay, so now your picture looks a whole lot different because now you've got some stuff to work with. If you just left it blank, if you hadn't done that, this is not going to work out so well. Okay, so Bofelo says A1 is equal to C1 because of alternate. Okay, so I'm going to fill in a different color. Let's do it in pink. Those things that we get from using our other geometry. So that's 50. I agree it's alternate, which is going to give me right there the 90-degree angle that I am looking for. Because if E1 is 90 because of interior angles of a triangle, then the diagonals bisect at 90 degrees and I'm done with my proof. That's all that was required. Okay, so I think some of you went down a windy road and that's okay. Sometimes that happens when you are doing geometry. If you wanted to do congruency, you would have had to do, if you wanted to prove that all the sides are equal, you would have had to have done 1, 2, I think 4 congruency proofs. Yeah, you would have had to do a lot of congruency because you have to prove that all of the triangles are congruent to each other. So AED congruent to DEC, congruent to EBC, congruent to AEB. So that would have been a lot of work. Obviously, look at the mark allocation. So if there was a mark allocation here, it would probably be like 4 marks. So we're going to go with that. So first we have to say that AB is parallel to CD. Why can you say that? Because of the opposite sides of a parallelogram. And only then can you start using alternate angles. Okay, so then you can say A1 is equal to C1 is equal to 40. Alternate angles,
50.
50, thanks. I'm looking at the 40. Alternate angles, AB parallel to CD. B1 is 40, it's given. Therefore, E1 is 90. Angle sum of triangle. And therefore, AB, CD, AB, CD is a rhombus. Diagonals bisect at 90 degrees. Okay. Right. Let's carry on. We've got more questions where that one came from. So let's go to this one. I think this is probably going to be our last one for the evening. So give it your best shot. Take now what you've learned from the previous 2 questions and try this one. Okay. Can't make things up. If we are asked to prove a shape, we can't use the properties of that shape yet. We must first prove it. Okay. Again, I'm going to leave you for about 3 minutes to devise a plan, a strategy, and then I want to hear from some people what they think, how we should do this. Lutando, I'll give you a chance at the end of the lesson to screenshot or to take any screenshots that you've missed. Just if I scroll away now, then the rest of the class can't see the question. Okay, so if you have a plan or a strategy so far, pop it in the chat or put your hand up. Let's hear, guys. If you have any ideas how you are going to do this. Tlakuso says AF is equal to CE. Okay. Let's start again with ABCD as a square. And that means we can fill in the properties of this square, ABCD. ABCD. So the small figure, that's a square. So 1, 1, 1, 1. And angles 90, 90, 90. And parallel sides. Okay, so all of that information we just get from the fact that it's a square. And then we also have DE is equal to DA. DE and DA. Okay, so we see here, this we filled in because of the square. So DE is equal to DA, so this will also be one marker. And then DF is equal to DC. Ah, here we go. Okay. All angles are equal for a square, that's right. And the corners are 90 degrees. So now we have to prove that ABCF is a trapezium. I hope you guys started by filling in the properties of ABCD that is a square, because that's really the key that unlocks this whole puzzle. If you didn't do that, if you didn't copy down the diagram quickly and filled in those properties, then I don't really know how you would have done this. Okay, so what can we say? Can we say that ABCF is a trapezium? If you are saying yes, you must give a reason. Why would ABCF be a trapezium? It needs a property. We never define things on what they are not. We define them by what they are. Okay, so what is the key property that we are looking for that would make ABCF a trapezium? Who said that? Sandile said AB is parallel to CD. Wonderful. That's it, Sandile. AB is parallel to CD. Where did we get that from? We got that from the fact that ABCD is a square. That's how we got those parallel lines. Well done, Sandile. So we're going to say ABCF. Actually, let's start and just say AB is parallel to CF. Okay, so CD, CF, these are all straight lines, so we can extend it to our trapezium here. So AB is parallel to CF. Why? Because of the opposite sides of the square ABCD. And therefore, AB, since we now have that key characteristic of the trapezium, ABCF is a trapezium. One pair of opposite sides parallel. Great. Okay. Now the next thing is, yeah, Anamika, you're right. AB doesn't equal CF. AB equals CD, but it doesn't equal CF. Now the next thing we need to prove is that ACEF is a square. So what are we going to look for in a square? And think about what is going to be the least amount of work, okay? The most efficient way to do this. How would we prove that ACEF is a square? We already have so much information here that makes it a square. You just have to find it. So here's our square. Well done, Gabriel. Well done. The diagonals bisect at 90, and the diagonals are also equal in length. That is why. So from our square ABCD, we could say that D1 was 90 degrees. And then from the given information, we can say that AD is equal to DE and CD is equal to DF. So they don't only bisect at 90, but they're also equal. Okay, so that is a key property of a square. So let's write all of that down. We can say D1 is equal to 90. Why? Opposite angles of a square. And then we can say DE is equal to DA. That's given. And DF is equal to DC. That's given. But DC is equal to AD. That's because of the opposite sides of a square. So what we actually get is that all these sides are equal. DE equal to AD equal to DF equal to CD. And therefore, that is a square. ACEF is a square. Diagonals bisect at 90 degrees and are equal in length. Okay. If you have a question, raise your hand, put it in the chat. Let's see.